All right, so what we're going to do here is we're going to introduce the concept of being able to find volume, specifically the volume of prisms, and then being able to find the volume of cylinders. And then next video, we'll look at cones and pyramids, and then we'll hit spheres, and then we'll do a little bit in class more of some composite figures, okay? Now, some composite figures are going to be mixed in here, and all that's talking about with the composite is that it might have a mixture of different things taking place, and maybe we have to do more than one step where we have to add the volumes of two different figures together because together they make one figure. Or maybe we're dealing with, let's say, where's a good example of this? Down here where we have two cylinders, but then there's this opening here, okay, this space that's taken up between them. And we would add together the volumes of the two cylinders and then subtract out that opening, okay? So that's what I'm talking about with the composite figures, and we'll kind of look at different examples as we go through each of these as well. But let's go back here to the top, and when we're talking about volume, what kind of leads to the idea of being able to find the volume of a prism is what they call the stacking principle, okay? For instance, you can stack CD cases, you can stack paper, you can stack money, you can stack coasters, just like these examples below, okay? And each of those cover the same amount of area, okay? So if we take a stack of CD cases, they cover the same cross-sectional area, okay? They have the same length and width. But as we stack them, the height increases, okay? That gives that three-dimensional aspect to it. But I honestly think paper is probably one of the best examples since it doesn't really have too much of a height. It does have a height, but it's almost negligible, and you don't notice it until you've stacked enough papers to realize that the height is increasing. So for instance, if we're looking at paper, the amount of area that is covered is 8.5. If we're looking at 8.5 by 11 paper, that would be our length and our width. Then as we stack the paper, the height is increasing, okay? And that height aspect, length times width times height, we know, going back to your elementary days, gives us our volume, okay? So that's the idea of where the prism volume comes from, is kind of like what they're saying here. Because in a prism, we have two translated congruent bases, okay? We talked about in prisms, we have two congruent bases. In this case, when we're talking about paper, the base would be our 8.5 by 11 paper. But all of the cross sections are also identical. So if you were to cut at a certain point along our prism, for instance, here, 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 the cross section where we're cutting at is going to be the same or identical to our base, just like a stack of paper. You can take any piece of paper in the middle and it's going to be identical to the 8.5 by 11 on top. Okay, so the cross sections are going to be identical. So to calculate the volume of a prism, okay, we calculate the area of the base. So we find that length times width of our base, and then we multiply it by our height, thus that stacking area on top of itself to fill in the volume of the shape. Okay, so when we're stacking, that's where that volume comes into play. So again, that plays in the idea of length times width times height. Okay, so to find the volume of a prism, you find the area of the base, that's your length times width, and since we're not necessarily always dealing with a square, we could be dealing with like an octagon or a triangle. That's why they call it the area of the base, and then multiply it by that height to get that volume aspect. Okay, now I am not going to pronounce this right, but let's just go with this middle name here, Francisco, okay, was a disciple of Galileo, and he investigated the stacking principle. And he came to define it as his own principle. He said, if the areas of the cross sections of two solids by any plane parallel to a given plane are invariably equal, they're congruent, then the two solids have the same volume. All he's talking about here, which I'll go back and read up there above, is that if we have a right prism or an oblique prism, as long as they have the same base and same height, then they have equal volumes, okay? So it says if we have two prisms that have the same height and the same base, irregardless of whether it's oblique or right, then we have the same volumes, okay? So like these guys would have the same volume, these guys would have the same volume, and even stacking our CD cases here would have the same volume, okay? Because the CD cases, the base is still the same length and width, and it still reaches the same height, so we still have the same volume, okay? Now, putting that into play, all this is saying right here is what we just talked about. the volume of a prism is the area of the base. That's key here. Make sure you understand that this is the area of the base, that capital B, times our height. Okay. Now, what I was thinking of doing, because there might be some individuals gone, and because some of these other figures we look at have a lot going with it, you guys can read these examples, and you can even read these examples here, and go through the process of understanding what they did to find the volume, okay? What I thought we could do is we could look at these examples that are not solved, go through each one of these, and then I want to kind of come back and look at this example just to explain through that guy, because we're dealing with a hexagon, okay? So let's start with these guys, okay? So to determine the volume of the following prism. So notice we are dealing with a prism here. Our base in this case happens to be a rectangle. That's what they're highlighting here. And what we want to use is that equation we just found, area of the base times the height. Okay? Well, if that's the case, the volume would be, what's the area of our base? Well, the base here, they tell us, is what is being highlighted right here. So they're saying this is our base. So how do you find the area of a rectangle? Length times width, right? So if we're looking at the length times width here, the length would be 20 times the width, which is 6. So that's the area of the base. Then the height is always perpendicular to our base, right? So the height would have to be this guy, okay? Think of it that stacking principle. I can look at any given cross section, cut it out, and it would be identical to our base. So we basically have a bunch of stacks of rectangles. So 14 here is the height. That gives us the volume, okay? So we have area of the base times the height, which is 14. Now this is where you take out your calculator, or you could multiply it by hand if you want to. But multiplying that all together, we should come out to get, whoops, there we go. We should come out to get 1,680 centimeters cubed. So don't forget this is cubed, okay? Because when we're dealing with volume, we have 3 dimensions. We have length times width times height. So that's where this cube comes into play, okay? So that would be the volume of that guy. Let's look at number 2 here, okay? What are they telling us our base is? Well, they're saying the triangle, right? So remember with a prism, maybe I should use red. With the prism, we have congruent parallel bases. So the base here are these triangles. Okay, now to find the volume, we take area of the base times the height. Okay, well, do we know enough information to find the area of the base? Well, let's see. We know that this is 5 based on this. We know that this is 13 based on this guy. But that only gives us a base of the triangle. That doesn't give us the height of the triangle. Okay, so we're missing the height of the triangle, because remember, for a triangle, the area of a triangle is 1/2 base times height. So if we're in this situation and we don't know the height, this kind of plays on what we talked about with those area problems with triangles. We can apply the Pythagorean theorem to find this height of that side. Okay, so we'd have 5 squared plus h squared equals 13 squared, our Pythagorean theorem. So 5 squared would give us 25, plus h squared gives us 169. Subtract 25 from both sides, and we get h squared equals 144. So now we got to get h by itself, right? So what's the inverse of a square? Square root. So we get h is equal to 12. So our height over here is 12. Okay, so now I have enough information to find the area of this base. Okay, so the area of a triangle is 1/2 base, which is 5, times the height, which is 12. It's got to be perpendicular to our base, right? And then we want to multiply it by, this height is a little bit different, okay? So this is the height of, now we're talking about in terms of volume, okay? So going from our, remember it's the perpendicular segment between, let's see if I can use this color, between the 2 bases here, the perpendicular segment between the 2 bases here. So our height in this case for the volume would be, let's see, there we go, 15. Okay, so we have 1/2 times 5 times 12 for the area of the base, then times 15 for that height in terms of volume, and now we can multiply that all together. Okay, so again, you can use your calculator for this. We have 1/2 times 5 times 12 for the area of the base, which gives us 30 times 15, times 15, and we get the volume is 450 centimeters cubed. Okay, let's try this guy here, number 3. Okay, again, using our triangles, and this one we're going to end up using Pythagorean theorem again, but that's okay. So again, when we're dealing with a triangle, the area of the base here, when we're looking for the area of the base times the height, the area of our base is 1/2 the base times the height of the triangle. Well, the base here is 6. What we're missing is the height, right? Well, this plays on the idea of some of those areas of triangles we looked at before. This is a right triangle, right? And I know that since these guys have tick marks, 2 tick marks, that they also must be 6. Now, if I draw my perpendicular segment here so that this is bisected, then this must be 3, and this must be 3, correct? So is that going to be enough information for me to find the height of this triangle? Yes, and there's multiple ways to do it, but we're going to use, we know it's an equilateral triangle, so we could use something else here, but I'm going to go ahead and use a Pythagorean theorem here. So we have 3 squared plus h squared equals 6 squared. Okay, so then we have 9 plus h squared is 36. Then we have 36, there we go, 36 minus 9. So we get h squared equals 27. And then we're going to square root both sides. Okay, now 27 we can try and break apart here to see what we would get. What goes into 27? Well, 3 and 9, right? And then 3's done. We can break apart this into 3 and 3. So we have 1 double, 1 single. So h would be 3 square root of 3, correct? Okay, and we could have played off the idea of special right triangles to get to the same answer, but since we're just kind of familiar with that. So the height is 3 square root of 3. Okay, so now I can use the area of the base. So volume here, the area base is 1/2 base, which is 6. This entire base is 6, times the height of the triangle, which is 3 square root of 3. Now that height, again, that height is for the base. Then we also have to multiply by the height, which is the perpendicular segment between our 2 bases, right? So we're talking about this guy, which is 10. So the height of our prism is 10. Okay, so now we want to multiply that all together. So we have 1/2 times 6 times 3 square root of 3. And then multiply that, we get 9 square root of 3 times 10. And we get 90 square root of 3, which is approximately 155.88 centimeters cubed. Okay, so that would be the volume of this figure. Let's look at number 4, and then, like I said, I want to go back to this guy, and then we'll talk about volumes of cylinders here. Okay, so looking at number 4 here, we have this, what would be considered a composite figure, and just like what we talked about with area, don't be afraid to break things up as separate figures. We could treat this like we have a triangular prism and a rectangular prism, and then just add the volumes together. Okay, so if that's the case, let's talk about the volume of the triangle first. Find that area of the base times the height, and see what information we have here. So they tell us that this side is 2 square root of 2, and it has a tick mark. Well, this also has a tick mark, so this side must also be 2 square root of 2. Okay. Well, that would be our base times our height, so that gives us enough information to find the area of the base there. Okay, so 1/2 times the base, which is 2 square root of 2, times the height, which is 2 square root of 2. Okay, so this would be our base, and this would be our height because of this perpendicular angle, right? Okay, times the height of the prism. Okay, well, now we gotta kind of look down here. Notice it says that this height of the prism is 3 centimeters. So this should also be 3 centimeters here. Okay, so times 3 for the height of the prism. So now we can multiply that all together here. We have times 2 square root of 2 times, times 2 square root of 2, and then multiply that. That gives us 4 times 3 is going to give us 12. Okay, so the volume of this triangle is 12 centimeters cubed. Okay, now let's also find the volume of the rectangular prism. Okay, and it's still area of the base times the height. For the volume of the rectangular prism, we need area of the base. They say the base is this guy right here. So base is 2 length times width, right? 2 times 6 is going to give us the area of our base, times the height, which is going to give us 3 here. So we have volume of the rectangle is going to give us 12 times 3, which is 36 centimeters cubed. Okay, so now putting that together, that was the volume of the rectangular prism and the triangular prism. So the volume in total would be 12 plus 36. Okay, 12 plus 36, which is going to give us 48 centimeters cubed. Okay, so that would be the total volume. Now, I just want to point out something on this top example here. This, you can read through it, but I just want to point out, when you're dealing with, let's say, like a hexagon, a pentagon, an octagon, one of those other regular polygons, it's still the same principle. The volume is area of the base times the height. But to find the area of a hexagon, that's when we kind of broke it apart into our special triangles. So this is a good review over that. And if you recall, the area of our regular polygon is 1/2 the apothem times the perimeter. And that's what they write out here, 1/2 the apothem times the perimeter, and then of course multiplied by the height of our object here, of our prism. Well, if that's the case, the apothem, they play off the idea of the 30, 60, 90. Notice this is 6 centimeters. So if we're using our special right triangle and we create our perpendicular segment here, then this would break apart into 3 and 3. Since we have a 30, 60, 90, the height would be 3 square root of 3. Okay, remember opposite that 60-degree side, it would be the same thing as 3 times the square root of 3, which gives us 3 square root of 3. And then times the perimeter, well, all the way around it's 6, right? So since we have 6 sides, 6 times 6 would be 36. That would be the perimeter. And then the height of this figure is 10. Okay, so that's just kind of like a quick review on that. And then, of course, if we multiply that all together, we'll get 540. But don't forget, if we're dealing with a regular polygon, it's 1/2 the apothem times the perimeter and then times the height. Okay. Now let's talk about cylinders, and that'll probably be the last thing we talk about here. But cylinders play off the same idea of that stacking principle. It just happens that the cross sections are circular, okay? Or if we're dealing with a regular cylinder, they're circles, okay? So it says the same stacking technique works great for cylinders as well. A cross section parallel to the base are all congruent circles, so using the same technique, we would get the same idea. Volume equals area of the base times the height. But what is the area of a circle? Pi r squared, right? So we just changed the equation slightly, even though it's still the same thing. It's pi r squared times the height, because the area of a circle here, even though it's the area of the base, the area of a circle is pi r squared. Okay, so to find volume, we would just take pi r squared times the height. And it says the cross section will be the principle will still work with cylinders as well. The cross section will be congruent circles, so the oblique cylinder will have the same volume as the right cylinder. Okay, so again, I'm going to let you guys be able to read through these. You can go through that. I want to work on these examples that are a little bit more tough maybe, and we can kind of go through those. So let's look at number 5 here. This is just a simple one. So the volume of a cylinder is pi r squared times our height. Okay, so with that in mind, what is the radius of our base? 4, right? So this is our base, and the radius is 4. So we'd have 4 squared times the height. Well, the height is that perpendicular segment going from our 2 bases here. This is our other base. So the height would be 10. Okay? Then we could just multiply that all together in our calculator. So we have pi times 4 squared, which is 16 times 10. So we get 160 pi. Then, of course, we could also write that as a decimal and go to 2 places. So this would be about 502.65 centimeters cubed. Okay, so that would just be like a normal, regular example of finding the volume of a cylinder. But then we can also look at examples where maybe it's not all given to us and we might have to actually determine something in order to help solve. And then there's some composite figures below. So like on number 6 here, they say the diameter, not the radius, the diameter is 5. And they say the distance here, almost kind of like a diagonal, the distance here is 13. What kind of figure does that make? A triangle, right? And that's going to be useful for us because when we look at the volume equation, pi r squared times the height, number 1, we have to determine the radius from the diameter, and then number 2, we're missing the height here, okay? So we're going to have to use that 5 and 13 to be able to determine the height. Well, let's first fill in what the radius is going to be here, okay? The radius is always half the diameter, so if the diameter is 5, what's half of 5? 2.5, right? So that part's okay. Now we just need to determine what the height of this cylinder is. Well, notice it creates a right triangle. So if we have 2 of the sides, we can apply the Pythagorean theorem to find the third side, the h. Okay? 5 squared plus h squared gives us 13 squared. We've actually kind of already done this one, and I think we're going to repeat it a few more times as we go along, but we have 25, 169, minus 25 from both sides. We get 144, and then square rooting, we get h is 12. So the height of our figure here, is 12. So that's what we're going to multiply by. So we have 2.5 squared, which is 6.25, times 12, which gives us 75. So we have 75 times pi, okay, times pi. And then if we go to 2 decimal places, that would be about 235.62 centimeters cubed, okay? So it'd be about 235.62 centimeters cubed, okay? Let's look at 2 more examples here. And I know this video is kind of long, but I just want to make sure we cover some of these harder examples. So like again, in this example, we have 2 different figures. We have a triangular prism, but then we also looks like we have maybe a quarter of a cylinder, okay? I say a quarter because if we went a full distance this direction, this would be half the cylinder, 3/4, and then of course if we went all the way, back, maybe this will stop, that would be our full cylinder, right? So it looks like we're dealing with a quarter of a cylinder. And all that tells us is that if we find the volume of the full cylinder, how can I find the volume of a quarter of a cylinder? We'll just multiply it by 1/4, or essentially divide by 4, right? So we're going to find the volume of the triangular prism first. Let's find the volume of the triangular prism, which is the area of the base times the height, okay? Well, again, with the triangular prism, the area of the base for a triangle is 1/2 base times height, okay? Now, since this guy right here is the radius of our cylinder, this would be the center, then the radius extending to any point on the surface should also be the same. So this should be 8, okay? So that helps us out a little bit here because now I have a right triangle. And just like we've been doing over and over again, I can find this missing side, the height, by applying the Pythagorean theorem. So we can apply the Pythagorean theorem here and say that 8 squared plus h squared equals 17 squared. 8 squared is 64. And then 17 squared, I believe we get 289. Okay. Then we're going to subtract 64 from both sides. And we get h squared equals 225. And then, of course, when we square root both sides, we should get 15. Okay, so the height here is 15. Okay, so now I have enough information for the area of the base of this triangle. It's 1/2. The base is 8, or we could even say 15. In this case, it's perpendicular here. So we have 15 times 8, base times height, and then multiplied by the height of the prism, which would be this distance. Now notice it should be the same distance as what we have here, so if that's 11, this should be 11. So the height would be 11. Okay, so then multiplying that all together here, okay, we have 1/2 times 15 times 8, which is going to give us 60, times 11 gives us 660. Okay, so that's the volume of the triangular prism. But then we also have to find the volume of, I'm going to put VC for that quarter of the cylinder. Okay, so we know the volume of a cylinder is pi r squared times the height, right? But this is a quarter of a cylinder. So if we multiply everything by a fourth, that's going to give us the volume that we need. Okay, so let's plug in the information that we know. We have 1/4 times pi times the radius, which they give us the radius is 8 squared, times the height, which they tell us over here is 11. Okay, so then multiplying that through, we have 1/4 times our 8 squared, which is 64, times 11. So we get the volume is 176 pi. Then if we go to 2 decimal places, we get 552.92 centimeters cubed. Okay, now that's them separately, so then the total volume, we add it together. You can just add it in your calculator, add it together, so that we get 1,212.92 centimeters cubed. Okay, so then we had to add these two together to get that guy. All right, one last question here that I want to look at, because it's also on it's a similar question to what's going to be on the concept check. Okay, is finding the volume of this guy. Now this is going to take a little bit of work. That's why I wanted to look at it. Okay, so we have to kind of break this apart into different sections. The first section I want to focus on is this hemisphere, it's not really a hemisphere. Let's back up there. Semicircle, jumping ahead into spheres here. So I have a semicircle here, sorry. We have a semicircle, and then notice that same cross section of a semicircle is also going to be here. Okay. Then if I cut out this section and just strictly focus on this guy, notice it forms half of a cylinder. Okay, so this forms half of a cylinder. So if we find a volume of the full cylinder, how can I find the volume of half a cylinder? Just multiply it by a half, right? So let's find the volume of this cylinder, which would be pi r squared times the height, and then multiply it by a half, right? Okay, so if that's the case, let's determine what the radius of this guy is going to be. This distance from here to here is 4, and then 1 and 1. So the total distance here would be 6, right? So if that's the case, remember the radius is halfway in between. So what would this distance here be? 3, right? So if the total distance from end to end is 6, then the radius must be 3. So for the volume of our half cylinder here, the radius would be 3, and the height would be 11. Okay, so now we can multiply that into our calculator, times 3 squared, which is 9, times 11. So we get 49.5 times pi. Okay, so we get 49.5 times pi, and then we can see what we get in 2 decimal places, which is 155.51 centimeters cubed. Okay, so looking at our semicircles as our bases, which creates our half cylinder, and looking at that section, that's what we're going to get for the volume of that guy. Now, what I would suggest that we do now is look at the volume of the rectangular prism, and then we'll take care of the opening there, that kind of like hole that exists there later. So let's find the volume of this rectangular prism, and then what we can do is we can subtract out that that half cylinder that exists down there below that opening, okay? So let's find the volume of this rectangular prism. So the volume of a rectangular prism is the base times the height times the height of the prism, or length times width times height, right? So the length across the base here is 6. So we have 6 times the width, which is 2, times the height, or the height of our prism, which is 11. Okay, so then we have 12 times 11, which is going to give us 6 times 2 is 12 times 11, which gives us 132 centimeters cubed. Okay, so right now we found the we found the volume of our our half cylinder there. Mixing up my words here. Our half cylinder there. Then we also found the volume of our rectangular prism. And now what I would do is I'd find the volume of that opening. So I'm actually going to call that VR, or excuse me, let's call it VO since we use VR. VO for the opening. Okay, so we have 1/2 pi r squared times h. Okay, so notice I went with a half again because this is half of that full circle. It's a semicircle, right? So we're going to end up with half a cylinder going from here to here, this being the other side of the base, and then back. Okay, so we're going to find that volume, and then we're just going to subtract it from the total. Okay, so if that's the case, we have volume of that opening is 1/2 pi r squared. Well, what's the radius? Well, this distance right here is 4, so if that's the diameter, then half of that would be 2. So the radius would be 2, and we still have the same height, which is 11. Okay, so then multiplying that out, we have 1/2 times 2 squared, which is 4, times 11. So we get 22 pi. Whoops, 22 pi. And then going to 2 decimal places, that would be about 69.12. Okay, so, jumped all the way to the top there. Okay, so finding the volume of this guy, we need to add our first figure that we found, the volume of that half cylinder, 155.51, plus the volume of that rectangular prism, or excuse me, did I say, yeah, half cylinder and our rectangular prism, just stumbling on my words there. So we have the volume of our half cylinder plus the volume of our rectangular prism, but then we need to subtract out that opening, which was 69.12. Okay, so we're adding the half cylinder, we're adding the rectangular prism, and then we're subtracting out all of this space that exists right in here. Okay, so going through that, 155.51 plus 132